All right, number 7. Let me go through it step by step, and then we can maybe do two types or two variations of these problems over the course of the test, over the quiz review, before I let you guys continue working. So number 7, this says, for what value of x is the series conditionally convergent? So there's going to be a range of values that we're going to look for. Anytime you see these types of series and it's asking about a conditional convergence or asking about the range of convergence, you're always going to be using ratio test. Okay, it's always going to be a ratio test problem. So let's look at number 7. These types of problems is always going to be a ratio test. Okay, so let's get through ratio test first, and then we can explore the how to interpret this. All right, so this is ratio test is limit as n approaches infinity of a sub n plus 1 divided by a sub n. So let's start off. And we're trying to get this to show us convergence. So we're going to step through our conditions for convergence. So absolute value of a sub n plus 1, replace all the n's with n plus 1. Divided by a sub n, which is the same thing as times the reciprocal of a sub n. So we're going to just jump to that step. Now, we know that we're trying to figure out an x value that will cause convergence. So if we want this to converge, we're looking for conditions where this is going to be less than 1. So we're always going to set it up this way. We're looking for x values that will allow my limit of this expression to give me less than 1. All right, good so far? All right, let's do some cleanup here. I'm going to break all these apart so I can kind of see what's left. X plus 2 to the n goes away. Okay. Now, I want to, x is going to be some static value that we're looking for. It's n that's moving. Okay, it's n that's moving. So what we're left with x plus 2 times n over n plus 1. Let me rewrite it different way so that it can be more clear here. This is the same thing here, but really we're finding the limit of n over n plus 1. What does this give us here? What's the limit as n approaches infinity of n over n plus 1? Just what? Just 1, right? So the only thing left is absolute value of x plus 2. So we know that this will converge whenever the absolute value of x plus 2 is less than 1. So we're down to this conclusion. Are we good up to this point? All right. So whenever you see an absolute value with a less than, you can always rewrite it without absolute value by saying this: x plus 2 is between 1 and negative 1. Are we good from here to here? Okay, so now I want to solve for x. If I want to solve for x, I'm going to subtract 2 and make it influence both sides of my inequality. So minus 2, minus 2, minus 2. So negative 3 is less than x is less than 1. So when x is between negative 3 and 1, my series will converge. Okay, but we have to test the endpoints. The endpoints, it may or may not converge at the endpoints. So the question is always at the endpoints. So it may be less than or equal to on this side. It may be less than or equal to on this side. It could be less than and then less than or equal to. So it could be any variation of less than or less than equal to. So this is still a question mark. But the range of values is set. We just don't know yet about the endpoints. Okay. All right, are we good there? So we're going to test the endpoints. We're going to figure out at the endpoints, what does the limit look like? What does the series look like? And can we convince ourselves whether the endpoints converge or diverge? All right, so let's test the first endpoint, -3. Let me write the series down again. So we'll test x equals -3. Okay. All right, so -3. -3 in for x. What's -3 plus 2? -1. So I have -1 to the n over n. What does this tell you? What type of would this converge? Converges by what?
Alternating.
Yes, converges by AST. So what if this did not have the -1 to the n? It would diverge, right? So what do we call this? Is this conditional convergence? Okay, so again, conditional convergence means if I were to strip away the alternator, is the resulting series still going to converge? In this case, if I strip away the alternator, it will no longer converge. It needs that alternator to converge. So we know that at x equals -3, this is a conditional convergence. All right, so we know that it does converge at -3, but that alternating series test, if we were to strip away that -1 to the n, my series will suddenly diverge. It will become a harmonic series. Okay, so let's test the other one. The other one is at x equals 1, right? So we're going to test x equals 1. Oh, sorry, my bad. Sorry, guys. -1. So if I were to insert -1 in for x, what do we get? 1 to the n. Is this an alternating series?
No.
No. This will just what? This diverges, right? Diverges absolutely. I'm sorry. This is still conditional convergence, but we call this diverging because there's no alternator, so it's a harmonic series. Diverges by p series. So now back to number 7. Question is asking, for what value is the series conditionally convergent? Then we say -3 because it is converging because it's got an alternating. But if I strip away that -1 to the n, it suddenly diverges. So -3 is our answer. But the process is you're going to step through a ratio test, set up your condition for convergence, and then work through, find that range of value. And sometimes the problem may ask you just for the range of condition of convergence. It may ask you for convergence at the endpoints, or it may ask you at the endpoints, is there conditional convergence? Any questions there? I want to do maybe 1 or 2 more of this so you kind of feel comfortable with that process. We're going to dig this. We'll see this process a lot in our next subunit, but this will show up on the quiz. All right, let me find another one for us to try. Page 7. Number 8. Page 7, number 8. All right, try that process. See if the process makes sense to you. So page 7, number 8. Go through a ratio test, set up your conditional convergence, or set up your conditions, and see if what we did for number 7 makes sense. Okay. I'll leave number 7 up here on the board if you want to check the steps here, but similar process.
Reasoning for this with the harmonic on the rim. I'm just wondering why, how we like get that conclusion that we need to do that. As opposed to that, especially if the multiple choice.
Mhm. Right, okay. So,
Okay.
right, so everything's backwards here. So 1/n versus very natural. This is smaller, which means this is larger. So this is larger than this, so this one. If this
Okay.
diverges, this also diverges.
So when you
Reducing
see a
conversion.
natural log, you say that you will, like whenever you see it, one over natural log, is safe to say that you automatically it's gonna go to the harmonic series because you know like that compared to approximate relationships, or will it change? Like will you need to do
It could change.
where,
I mean, this is a multiple choice question. They
Yeah.
could, they could easily pick a polynomial or exponential.
Yeah.
And we can get, if we know this relationship, it takes us a long way, right? We can use that too, yeah. So,
okay,
yeah.
so.
Because
how
this,
did
I know
we-
this is direct comparison. So direct comparison is not as clean, right? It's kind of
Yeah.
like, okay, you kind of have to look at every situation. It's not like limit comparison. Where
So how would you differentiate between this and this, then how would you pick one over the other?
got it. Well, this is a converging series.
Okay,
So I'm never going to be able to do a direct comparison with the converging series
okay,
because this is larger than this. But if something's larger than a converging series, I'm still stuck in that gray area. It may converge, but it can also diverge.
okay, so it doesn't achieve that like that condition that was like mentioned earlier.
Right. The whole like, truck
Yeah.
falling. Yeah. It has to, that's right. It has to be greater than the diverging or it has to be less than converging. If it doesn't quite fit those criteria, then it's not a strong argument.
Okay, so when kind of approaching this question, then what would you just like make sure you understand like this one could diverge and so this one converges, then like go from there?
Yeah. All right, thank you. Mhm.
That's what I'm trying to freeze in my head.
All right, let me go over this, page 7.
They tested from the.
All right, so for number 8, we set up our ratio test, right? Guys, let me go over this. So my a sub n plus 1 divided by a sub n. And I'm just expanding everything out, see what's left over. And the only thing that's left over is the absolute value of 7x minus 3 is less than 1. Are we good up to there? All right, so now set it up. Both sides less than or equal to -1 and 1. And then you're just algebraically moving things away from the 7x minus 3 on both sides. So add 3 to both sides, divide 7 from both sides. So the ones that you only have to worry about are the endpoints. Okay, you only have to worry about the endpoints. So let's plug 2 7s in for x and see what we get. We plug in 2 7s in for x, we get -1 to the n over n. This is an alternating harmonic series. We know this is conditionally convergent, so that is a good fit for. So 2 7s is a good solution there. But let's just test the other one to see what happens. Okay, the other one is 4 7s. If I plug 4 7s in, I'm getting a 4 minus 3, which is 1, 1 to the n over n. There's not an alternator here. This is going to be, it's just a diverging series at 4/7. So there is no, we only are looking at conditional conversions if there's actually an alternator to give it that, every other term being negative. So only 2/7 fit that criteria. Are we okay with that process? All right, so pages 1 through 5, are there any questions, any problems you want me to go over with you? Yeah. So number 15, we're looking for a sum, right? So the sum is a sub 1 over 1 minus r. My first term is whatever my lower bound starts off as. So if I plug 0 in for n, r to the 0 is 1, 1 times 10 is 10, so my a sub 1 is 10. And my ratio is just r. I don't know what r is yet. And then I'm just algebraically solving for r. It's already like. Yeah, guys, make sure that you never assume what the first term is. Always plug in that lower bound to tell you what that first term is, right? Sometimes it's just 10, sometimes it's 10 times, it could be 10r, but it really depends on whatever that lower bound starts you off as. Okay, good. Any other questions? Yeah. Yeah. So 16, what's a little strange here is we don't know exactly what this is doing. We're assuming that maybe that could be an alternator, but we need to check, right? It's we don't want to assume anything. So let's just test it out. Let's plug 1 in for n. Let's plug 2 in for n, 3 in for n, 4 in for n. Is it an alternator? So it is, right? If I plug 1 in, I get 1. If I plug 2 in, I get -1. So then this upper portion is really acting as an alternator. It's really basically the same thing as -1 to n minus 1. And if I can see that relationship between this and this, then I'm really just looking at this problem, right? And this problem is an alternating harmonic series because it fulfills the condition for AST. And it's conditionally convergent because if I were to strip away that alternator, it becomes a harmonic series which would diverge. So this series converges conditionally. Okay. Any other questions, page 1 through 5? Okay, so start with page 6. And I want to pace us through this page here. So after a few minutes, I will walk through 1 and 2. And after another few minutes, I'll walk through 3 and 4. And then our homework is to get through worksheet 2. See.
When I was through it, I just went until I got here,
Okay.
and I thought that it looks similar to the one that we did for number 7.
Mm-hmm.
So that's my faith. What
Yeah.
exactly does it mean when it's asking this conditional conversion?
Conditional convergent means that it has to be an alternating series.
Mhm.
An alternating series that would not converge without the alternator would be a conditional conversion.
Okay.
So for instance, -1 to the n over n is conditional convergent because I would strip away that -1 to the n, it would suddenly diverge. But if I have -1 to the n over n squared, this would be an absolute convergence. If I were to strip away that -1 to the n, I still have something that fulfills convergence by p series. So this would be considered absolute conversion. Absolute conversion means something that does not require the alternator to make it converge.
So both absolute and conditional conversion are just for alternating series.
Exactly.
Okay.
Oh, over here.
Oh, no, again.
Oh, where did that negative one
Yeah.
go?
The ratio has.
I think I brought it here, right? You asked me where that negative one went?
Yeah.
I have it here.
Okay.
Or are you asking why does it disappear from the limit?
Yes.
Okay, okay. So it's like, let me do an easier version of this problem. What if you had a limit like this? Oh, the limit of this.
Oh, then it must be your report.
Their report, right? We're basically just taking out the highest degree, ignoring anything else and just pulling the coefficient. So same thing here. Think of your 4 to the n as your highest degree, and you're just pulling the coefficients in front.
So it's like ends terms are
Like, well, what you're doing is you're doing one other comparison, where you're doing the right comparison, which is not.
You know what? I could do ratio cos. I can do number 2 on this one. I can't do the other one. I can barely do that. That's. Isn't it just like the?
It's just
It
Okay.
needs to be, something that is in this form. Has to be like that. If I start adding things to it, I'll have to go through either limit comparison or direct comparison. It's not as clean as you would like. Even though you may have a comparison partner, it is still not a perfect fit.
So I did LCT.
Yes, but LCT wasn't. But it could be LCT instead.
Same number, like same like.
It's right. I just need to see, how did you know that was right? How did you know? It's because you found a limit and you're comparing. Because this 3/8 doesn't justify your answer. What is the difference? The fact that relates to 0, that is how you make it. This is in terms of.
In my explanation. I'm taking a little bit smart, I'm not going to get some further acid.
That's true. But against term test is going that version because it doesn't answer the sequence conversion. Zero. So if I'm not comparing with 0, then when we're on track, that doesn't prove. On the direction of the page one. I'm good.
I'm just gonna.
All your steps. I know that. It's like, that's fine, it's like, but I need to see your limit. And the fact that you are like that. And you're improper.
Yeah.
And finish you until.
And. One over.
I wrote it's just words like language.
It's because. It's because.
Yes, but the problem is. Oh.
Wonders if I was.
Was there one big negative one?
Like I know.
Oh,
No.
You just ignore it, okay.
Oh, yeah.
That's true. I'll see you before. Then I'll get it. Actually, because I'm on Thursday for all state. So when we take their course tomorrow. Yeah, so like actually. Not so, but every day, so I take it on Thursday and it's on Thursday. Yeah, and you're not here Friday either, so that's the next Monday. Monday or Tuesday. Yeah, you know.
So
Oh, then 1/6. Yeah, you should actually. Because then you get an extra. Yeah, they really go. He's still gonna make me go. But still.
Right. The way that I
Do my. Oh, well.
Go check out what I will talk to like 3. Oh, yeah. It's like he said.
You sound like that's our fine guys.
I was gonna say like. Let's say we were also didn't know this. We were looking at each other.
Did you also?
Yeah.
Oh, I
I don't know why it's like tweaking. Like,
Oh,
this first.
Oh, no.
Yeah.
They
actually. We must have one of those willing still that we took there some time for like just. That's a good thing. Yeah.
We went, got 9:57.
Wait, what is
Dude, it's good.
I'm at
Yeah.
I'm actually like,
And then he was like, maybe just.
I want to get up.
Wait, how long? How long to get up?
We all like kind of went on there, and then it just like snowballed.
You guys said it was the budget anyway.
No,
It was all stream of meditation.
it wasn't straight line memorization, but like we were.
There's like. Friends. No, just like yeah, because there was check your own down. Actually, like, no, but like, it's only yeah, I guess I don't know. I don't know. That's a great question. Yeah, that's I'm trying to get it. Okay, I'll ask Judge Hags. What's it now?
I just always use my phone. Like
Nothing but. So already. Actually, no. I didn't. And then they're looking at that's my knowledge. Oh. I'm like,
How does it, what did you change?
One thing would be for the August time. I know that was like, oh, yeah.
no, it's like. And that's really
Oh, stimulus. Oh, yeah.
But
Stimulus, bro, I think that's kind of. You go like the.
Oh, I got some big thumbs.
You go like the worst.
No, Liam, my first question.
Yeah, you know, like how does this like how is one
Oh, it's the one I got.
No,
Not really. Yeah, I kind of bring up to pick up. Now I got like.
Oh yeah, I forgot, got it.
Friday.
It's a big word from like feel like nice for your back now. It's less than and like go like
I've seen like zero hands that take you on the ground. I've seen like two. You already know that now that I have the practice, definitely have like 5 levels.
Like that one. I just like brag.
we got
Yeah.
That is people.
And like I one didn't really make a difference. At the end of the year, like standardized for 1% difference or something.
in 3.
These are not.
Oh.
Today. I think one minus is 0 to 5 to 2.
You always do.
And from 0 to 5 to 2.
So what? Like, actually.
I don't think 1.5 is landing at the symmetrical place on both of those. Right?
I know it's an odd. You're right.
I think.
No, same.